So today we're gonna talk about the conversion between rational exponent and radical exponent. So the word rational means fraction. Okay? So whenever you see the word rational, it means and the word radical means root. Right? So we're going to convert between the two today. We're going to go from radical to rational and from rational to radical. Okay? So recall that a to the power of m over n it can be also written as the nth root of a all to the power of m, or you can also write it as the nth root of a to the power of n. Okay? So you can do either way, both of them are correct. The conditions is that n has to be greater than 1 and it has to be a whole number. Okay, so where n is a whole number that's greater than 1. Now, radical, as I explained earlier, means there is a root, and then rational means that the exponent is a fraction. So when you read the question, just make sure you understand what the question is asking. So rewrite each expression using rational exponents. So we're moving from the radical, which is the root, to the rational. So if I want to write this as a rational exponent, it will be 25 to the power of a half. Okay? Why to a half? Is because you see there is an invisible 2 right here, right? And if I want to change it into a fraction exponent, it's going to be 1 over 2. Yeah.
Why the square is gone? The square root is gone after we change it to fraction.
Yes, right. Right. So instead of doing this, you're actually writing this.
Okay.
Okay. So this and this, they mean exactly the same. Okay. So it's either one or the other. Right.
For both answer for both radical and
It's gonna be 5.
rational would be 5.
That's right. But the question is asking you just to write it in rational exponent, not to find it.
Oh.
Okay. How about the next one? To the power of 1/3. Now when I put the power, I have to put in bracket because that negative 125 is under the radical, right? So I put it in bracket and I put 1/3 as my exponent. Okay, how about the next one?
1.05 power of 3 and n and
So the power of what?
4 over 3.
No.
3 over 4.
3
3
over
over 4.
3 over 4. So whatever is in the radical has to go in the denominator, right? So the whatever is in the radical, so that number that you see in the radical right here,
Yes.
has to go as your denominator.
Okay.
And then the other exponent has to go in the numerator. Okay? Now the next one is asking you to rewrite each expression in radical form and then evaluate. So in this case, it's asking you to do both, right? Radical form and then evaluate. So So how would I write the 81 to the power of half as a radical?
Just root,
Square root.
81 inside the
So the square root of 81,
Yeah.
which is
9.
9.
And then the 3 on the square root.
it's called a cube root.
Cube root.
Yeah. So cube root
Minus 64.
and negative 64 inside the cube root.
Okay.
8 equals root.
Negative.
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 Third one.
Is it negative?
Yeah,
Check
it
for
will
me.
be. It will be negative because it's cube.
But would it be 8?
8 minus.
Ah, no.
Okay. Check yours.
4. Because it's a cube root, not a square root. Okay. Okay, how about the next one?
Not cube root, so.
So the what I write in the root?
And 5.
No, 4.
No, 5.
5.
5.
Yeah.
5, 32 to the power of 4. You can write the power of 4 here, or you can write here. It's the same. You don't have to write them twice. Pick one. Pick one and okay. And then no matter what, how you enter it in the calculator, it's going to give you the same answer. Okay? So in the calculator, you can enter 32 to the, you can enter 32 to the power of, and then open bracket 4/5. You must open bracket. So you can enter that. Or you can enter the 5th root of 32 to the power of 4. That also should give you exactly the same answer. Okay? So you pick one and enter it in the calculator. What do you guys get? $16. So your calculator will too much pieces.
Okay, the same
I would
answer.
enter it like this. Because then you make the 32.
Like my calculator.
Bro, look at this. When you hit second function here, I guess so. I don't know. I don't think
That's easy.
so.
If you want to do this, you get the 32.
32.
Second, this, time.
160.
That gives you this. And the power of 4.
Is it gonna be 160?
No,
No?
16.
We have 0. Extra 0. So how do you just,
So what did you do?
this is the second function. We put 5 and then the square root.
So you put this one?
No, no,
So you
no.
should put this one.
Oh.
So we 5, second, this,
Uh-huh.
and then 32. And to the
That's a lot of work.
Okay, otherwise you're doing 5 times the square root of 16.
Oh.
Of 32, sorry.
Got it.
Right?
Simple, man.
Okay?
That one.
I need you guys all to look, make sure that you're getting 16.
16 for
I
what? Which
got
number?
it.
Yeah.
Sorry, this,
Yeah.
my brother, he took mine.
So-
No.
The 5th root, 32 to the power.
Eight, 5.
So you have to do
Second shift, this shift.
Yeah.
shift
No, just one minute.
Yeah.
this, 32 to the power. Okay? So you have to use the shift this one. Okay, you got it? Alright, now,
What is the use of number
Yeah.
one? How we
Then
use
the
it?
exponent.
this is the
Exponent
fifth
four,
root.
Yeah.
And
Four.
what is four?
The 4 is the to the power of
Okay, first we are taking out the root, fifth root, and
Yeah.
then we are
Powering
out.
to the
Okay, so
yeah.
that's why.
Okay? Are you guys okay with this? Okay, now, next one, it gets a little, I want you to solve for the variable x. So you have to isolate for x. X equals 2. And how did you get that? Did you just do this and check?
No, but I put 2 to the power of 4 is giving me 4.
So let's call guess and check.
Yeah.
That's not what we did.
It's actually a mathematical thing, guess and check. It's not like just playing games. It's actually mathematical. Okay. Now, remember if you go back to grade 9 and 10, right? They tell you that you need to isolate.
Yeah.
Yeah? So I have x to the power of 4. If I want to isolate x, so I want x by itself. How do I get rid of that power of 4?
Square rooted?
Fourth root.
Fourth rooted.
Yeah, because the square, if it's x squared, then you square it, right? You can't do the same thing for the fourth root. So that's right. So you want to get rid of the power of 4, you have to do the fourth root, right? So you do x equals the fourth root of 16. Okay? And then when you do the fourth root of 16, you're going to get 2.
Look at this.
I want you guys to try it because I want to make sure that you know how to use your calculator. The fourth root. So you have to do the same thing. 4 shift.
So we start from here, right? Second function.
Yeah.
4.
No, you have to put 4 first. We do the second function.
So 4.
4.
And this one?
Shift. Shift first.
Mhm.
Then down.
Okay.
Then 16.
Simple.
Okay? You got it. Because your calculator is backward. You have to put 16 first.
Yeah, I put 16 then second shift.
Yeah, and then that and the 4. Okay. Are you guys okay?
Mhm.
Four is next.
So put 4.
4, yeah.
No, you have to
Then
put
you have to
shift.
use this one. What about this one?
No, 4.
You're right. I should pull it out. I should pull it out just in case it makes a error.
Okay, and now.
Okay. Now, the reason why we don't like guess and check is because of this.
Yeah.
Good luck with guessing
We
and,
can
guessing and
guess.
checking.
I'll
Okay, you guys can do it if you want, but it's.
I would get sick if I missed this one, bro.
Okay, so that's why we need to learn a mathematical trick, right? So what's the opposite of 3 to the powering 3 over 2?
2.
What is 2 over 3?
Okay, so I know what you're doing here. You're rewriting this as a radical, right?
Yeah.
That's what you're trying to
Yeah.
do. Okay, so let's write this as a radical. Maybe it's easier for you then to isolate. So this is the same thing as this, right? I haven't done anything. I just rewrite it in radical format, right? Okay, now I want to isolate for x. I want to get rid of the square root. If I want to get rid of the square root, what do I do? Square.
Square.
Square root, square root, right?
Okay.
So the opposite of each other. So if I want to get rid of that square root, I have to square,
Mhm.
right? So if I square, right, then this and this will cancel each other,
Oh.
right? So then you'll be left with x cubed equal to, what's negative 27 to the power of 2?
Bro, I can use yours.
7,
20.
20.
Yeah, that's right. Good.
Okay, so you see that? You see what happened right now? So I got rid of that square root. Then what can I do to get rid of the cube?
Then we have to.
Cube root. Cube root. Right? So now I have to cube root both sides. Right? When I cube root, it will get rid of that cube. So x equals to, what's a cube root?
So minus 7.
Yeah, when you raise negative to a power of 2, it becomes a positive. Right?
That's 9.
No. The only thing I don't like about this is that it's a positive 9. How am I getting a negative here? Can you do me a favor? Can you do 9 to the power of 3 over 2? So 9 to the power of bracket 3 over 2.
Open bracket.
Positive 27, right?
Oh, what is the fraction? It's a power.
Can you do negative 9 to the power of 3 over 2? Should not work. It doesn't work. It's a negative, right? Okay. All right. Now, if you guys look what happened here, right? I'm gonna take this to the side for a second. So if you look what's happening here, so first thing I have to do is I raise it to the power of 2, then I have to cube root it, right? So basically what I did is I took the negative 27, I put it to the power of 2, right? And then I cube root it, correct? Can you guys write this? So this is exactly what I did for both steps all together, okay? Let's write this as a rational. So if I want to write this as a rational, what would it be? Negative 27 to the power of what? To the power of 2?
Over 3.
Over 3.
Yeah.
Okay, look here. What do you see? What's the difference between the two?
Just what flip?
It's a flip. Okay? So this is what's happening. You can actually take your power, right, your exponent, and then if you want to do the reverse operation, you'll do it you raise it to the power of the flip, right? So if I'm looking at this, I can do it in one step by raising it to the power of 3 over 2, and then done. Okay? So that's technically, I mean, when I do it myself, when I see this, and I want to isolate it for x, what I do in my head is I do the reverse. So I do 64 to the power of 3 over 2 and done. I don't do the step by step. Okay? If you guys want to do the step by step, that's totally fine, right? But also I would like you to be aware that there's an easier way, right? And the easier way is you raise it to the power of the inverse, of the reciprocal. Okay? So, I erased this answer. What was this answer? Okay, so if I want to do it step by step, what's the first thing that I have to do there?
Yeah. Square root it.
No, cube.
Either way,
Because
it would work. Cube first, square root first, it's the same thing. Let's write it as a radical. Okay? So it's the same. If you want to cube first, that's fine. If you want to square root first, that's fine. Both should work. Okay? So let's cube first because I like to get rid of that cube root. Okay? So if I want to cube first, what do I get? 164 to the power of 3.
262.
Say
26,000.
so 26
262.4.
262,144. Okay, then after that you have to square root, right? To get rid of the square. So what's the square root of that?
How do you put square root in front?
5. Okay, so if you actually do what I told you to do, so do 64 to the power of 3 over 2. So do 64
4
to the power of 3 over 2.
to the power of 2, please. This is, yes, good way. No way.
You have to do 64 to the power of open bracket 3 over 2.
Okay, so this
Power?
is 64. Power is this one, right? Okay.
No, that's square. That's power.
Okay. Oh, 64. This is power.
Open bracket.
Okay. 3 over.
Yeah, the
How we
same
put
answer
over?
is coming.
Oh.
Right, so if you do power and then open bracket 3 divided by 2.
Yeah?
So you can
We sound like dummies now.
So if you do this, you can do this. Power and then 3 divided by 2 close bracket.
Yeah, man.
Okay? So you guys get the same answer, right?
Yeah.
Right.
Okay. You couldn't?
Simple.
So you put brackets?
My bracket is not working.
This is power. Power.
Come on.
Yeah, I don't know.
We got working study. Law justice. Criminal.
Yeah.
Florida.
Yeah.
I might get out of this.
For Orlando?
Where are you going?
Orlando.
All right.